So we saw about route summarization, ABR, ASBR, followed by, we are seeing now a default route. If ISP provides you a default route, in your router 1 here in this picture, so this R1, router 1, R1, receives a default route already, okay? ISP is providing a default route. ISP, somehow, they provide you a default route. Maybe you will be running an eBGP. BGP can advertise a default route. You know that? You learn it. When we go to BGP, you know it. BGP can provide a default route. So when R1 receives a default route via BGP, you can use the IGP protocol, OSPF, to propagate this information to all the routers in the OSPF domain. So you may have many areas here. All the areas in OSPF will receive, every router in each area will receive a default route dynamically on the routing table. How is this possible? This is the command. You need to simply type this command, default information originate on this router. So here you don't have BGP, OSPF, no OSPF here. Wherever the OSPF neighbor is, you will see the advertisement going there saying, I'm the default router. Come to me, come to me. R1 will invite everyone to send all the unknown destinations to R1. And R1 will forward it to other routers. See, it's so easy in OSPF. Just one command, default information originate. That's it. But for this command to propagate default route, you must have a default route already in R1 receiving from ISP. In R1's routing table, if the default route is not there, this command will not propagate any default route to OSPF neighbors. In order to advertise default route to OSPF neighbors, R1 needs to have a default route, either use statically writing or learn through some other source like BGP. All right. So what if I don't have a default route in R1, but I still want to advertise the default route? I repeat, I'm not receiving any default route from the internet service provider, but I still want to propagate a default route to every OSPF neighbor. Very simple. Along with this default information originate command, you use the keyword always. You use the keyword always along with this is an optional one. If you put always, even when there is no default route in the routing table, this router will start propagating default route. See, if you read the second line, you will understand. The always keyword allows default route to advertise even when the default route does not exist in the routing table. Is it clear?
Yes, sir.
Now, for the default route, optionally you can advertise some metric, and then metric type like E1 or E2, because this is going to be advertised as LSA type 5. LSA type 5. The default route will be advertised as autonomous system summary LSA. Is it autonomous system summary LSA? No. It is autonomous system external LSA. Means coming from internet, coming from other sources. So, and if you want to do some filtration, you can add route map. Let us not get into route filtering. That is a separate chapter for us. Let's see an example here. You see, we got two service provider providing a default route. and you want to propagate this default route to all the OSPF neighbors. Because you have two ISPs, you got two ASBR1, ASBR2. And your preference is to leave the autonomous system via ASBR1, meaning you prefer to use ISP A as primary. If only ISP A is unavailable to reach, then ISP B. How do you achieve this? Along with this default information originate command, you put metric. Lower the metric, high preference. Isn't it?
Yes.
Yeah. So do you have this topic well understood? Default information originate.
Yes.
All right. Did you understand that always keyword when to use, when why to use always keyword?
The always keyword is used when there are no input or we getting any input from no one. So you use it to propagate the default route. It doesn't exist.
Yeah. Even though when there is no default route statically written into the routing table, you want R1 to take responsibility for default networks, unknown networks, then you may say default information originate always. We should do this labs and see, only then it will be more comfortable, understandable. Yeah? So we need to do lab on this one. We need to do lab on the uh, summarization. We did authentication. We need to do lab on authentication. We need to do lab on default information originate and default information originate always. And then we also need to do a lab on auto cost, right? So those are the things we need to do in lab. Now this chapter is over. In this chapter, what you learned is about the ABR summarization, ASBR summarization, virtual link, default information originate always, along with the cost. Now, can I ask you some question?
Yes.
Now, what is the LSA type that will be used to carry the advertisements originated from ASBR?
So this is type is type 5.
Very correct.
However, okay, I was going to elaborate. However, when it comes into the router ISP, propagated across through the ABR in return to type 4 that carries the router ID of the ASBR.
No, I'm confused with your answer. Can you repeat, please?
Okay, so this type 5, when you inject the route on external source,
Mm-hmm.
that's in type 5 LSA.
Okay. So that LSA, when it goes to next area, will it be seen as type 5 or anything else?
Type 4 becomes type 4 like what you're saying.
Sorry, that's a misunderstanding that you have. All right, I want to fix that. That's not the way. That is not the way it works. Okay, let me take you to another lesson, a previous lesson, a previous chapter. You see, the networks are coming from the ASBR. The external networks are coming from ASBR. It originates from ASBR. In all the routers of area 1, it will be seen as type 5. Even in the routers of area 0, it will be seen as type 5. Even in the routers of area 2, it will be seen as type 5. Type 5 will never get changed to type 4. Never. You see, I want to repeat. Type 5 is the one which carries networks that are coming from other source. Networks, there may be 100 networks or 1,000 networks. And all those 1,000 networks needs to go to every area in your OSPF domain. So it will be carried only as type 5. Then what is type 4? What is type 4? We need to understand. Why do we need type 4? Answer is here. In order to find the ASBR, type 4 is used. In order to find, that's all. Nothing more than that. In order to simply know who is responsible to give me type 5. I repeat, in order to know who is responsible to give me type 5, that router ID of that ASBR which generates type 5 is carried as an advertisement in the form of type 4. You got it? Type 4 is not carrying those 1,000 networks. Type 4 is carrying just only one ID, which is the router ID of ASBR, so that all the routers in every area will know who is responsible, which router is responsible, which router ID is responsible to provide type 5. If you see the next picture, if you'll see the previous page, you will know. You see here this picture. There is an ASBR in area 1. Every router will send an LSA, which is called router LSA. Do you know that? We know that, right? Type 1. So type 1 says, hey, I'm a ASBR, I'm not a normal router. Type 1 says, here also type 1 goes, but this type 1 is something special. This type 1 says, I am a router where the redistribution is done. And this information goes up to the border. The border says, okay, you are a special guy. I have to make you as type 4, meaning the advertisement, the router ID that is coming here. Let's say here this router's router ID is 1.1.1.1. That 1.1.1.1 only, that is the only information that's coming, and it is now converted as type 4. So every router will know who is ASBR. 1.1.1.1 is the ASBR. Yeah, 1.1.1.1 is the ASBR. Everyone knows that 1.1.1.1 is the ASBR. How? Type 4. But that 1.1.1.1 is not going to bring this 30.1.1.1 slash 28 and 24.2.2.2 slash 30, all those network informations of the internet. Type 4 is not going to give you information about 30.1.1.1, 24.2.2.2.2. Type 4 is simply saying which router is going to be ASBR or which router is going to give those external networks. It is only type 5 carries the networks, the prefixes that are coming from other autonomous system. Okay, is this clear? Sorry, you are in mute. You are in mute. Do you hear me? So let me quickly revise, because I found that you have some misunderstanding. See, type 1 is an LSA that is originating from every single router. But this LSA that originates from area 1 will never go to area 0 because the scope of type 1 is within the area. It is flooded only within the area. It does not cross ABR. Likewise, type 2. Type 2 LSA also never does not cross the border, does not cross the ABR. Now, what is the difference? This one is originated only from the DER routers. Now, type 3 LSA is the one which is going to translate all those type 1 and type 2 as type 3 and get flooded to all other areas. So other areas knows about area 1 via type 3 LSA. Type 4 LSA is the one which is originated from the ABR, just to tell that in area 1 there is an ASBR. Just the router ID of ASBR is advertised. Type 5 LSA is the one which originates from the ASBR itself. What do they carry? They carry the networks that got injected into OSPF from some other source. Again, this is not going to summarize by default. We need to summarize, and we learn how to do summarization. All right. When I type show IP OSPF database, I can see that there are 3 routers in area 0, and then there is one DR among these 3. This guy is the DR. This guy is the DR, and then there are some networks learned from other area. These are coming from other area, type 3 LSA. Okay, this is not a chapter which we supposed to see. I just took you back one step to remind you the difference between type 3 and type 4 and 5. So now we are okay. We have even finished this chapter. I was asking you some questions. So now let me ask you one more question. Are you ready for this? One more question. No. Now, when I say default information originate, R1 will advertise a default route to all the OSPF neighbors. What LSA type will be used to carry this default route? Exactly, type 5. Okay, let's move on to the next chapter. Configuring OSPF special area types. Special area types here means not an area with something, like what you see in EIGRP. In EIGRP, we have big autonomous system, and we do summarization anywhere we want. And in order to reduce the routing table updates, the summarization helps a lot, but still it's not hygienic. It's not really good. Doing summarization anywhere you want, that's not really nice. OSPF was very neat. You do summarization only on the ABR, and for the external network, you do summarization only on ASBR. Along with the summarization, OSPF supports something called stub areas, special area types. Here means stub areas. Don't compare this to EIGRP stub. EIGRP stub is only when we have hub and spoke. Do you remember stub in EIGRP? You forgot? Okay.
I'll look at my notes.
Okay, I'll try to help you recall. You see, to avoid sending queries to many hops, we we configure EIGRP stub to say only this much you can expect from me. That avoids struck in active scenario, SIA. Struck in active is after 3 minutes, if the query response don't come, they reset the connection. That is struck in active, SIA. Don't worry, I'll take you to the EIGRP chapter later. Let me finish today this OSPF stub, okay? Meanwhile, you go through the notes that you took when you were studying EIGRP stub. Have we covered EIGRP stub? I'm just asking. Do you remember that we spent some time on stub summary, stub connected, stub static, stub receive only? Do you remember those things? Sorry, your voice is breaking again. Okay, you remember those stub topics we covered? Okay, okay, all right. So let me now take you to OSPF stub areas. OSPF also have got stub area, but this has got something big benefit, a very big benefit. Not something. It's just it has got something. It has got a really great um, feature. This is a very good feature, a very great feature, because the word stub is used in EIGRP. Don't compare EIGRP stub and OSPF stub. EIGRP stub is very limited. OSPF stub is something very great. We're going to see the 4 types of stub that we have in OSPF. In Cisco, there are 4 types of stub areas. They are called special areas. Whereas in other vendor, there is only 2. Other vendors, as per the standard, there is only 2 stub areas, 2 special areas. Whereas in OSPF, we have 4 special area types. Number 1 is called a stub area. Number 2 called as stub summary. Stub summary. Number 3, not so stub area. Number 4, wait a minute. I used the wrong word. Okay, the number 1 is stub. Number 2 is totally stub. Actually, stub summary is EIGRP, okay? Because I was talking about EIGRP, I mistakenly used the word stub summary. This is totally stub. This is a Cisco's idea, not in industry. You will see. This is the industry standard, RFC standard stub. This is Cisco. Only on Cisco routers you will see this type. The third one is not so stubby area. And the fourth one is also Cisco. Total not so stubby area. These are the 4 types of stub in OSPF. OSPF special area types. If you see here, I'm seeing 3 areas. One area in the left is configured as stub area, which means this area will never allow type 4 and type 5 LSAs. What does that mean? This area is not going to see any routes coming from EIGRP. Can I say that? Yeah. EIGRP routes come inside OSPF as type 5. The redistribution where you do between EIGRP to OSPF is for type 4. Both are not going to be allowed inside. Please ask me some questions if you are getting in your mind. You should not wait. Ask questions. You see, I'm saying when I configure this area system, let's say this area is area number 10. When I configure area number 10 as stub area, area number 10 will not see any type 4, type 5. That is what here it means, does not accept external LSA. Type 4 and type 5, they are talking about what? External. Type 4 is saying who is responsible for external networks. Type 5 is saying what are the external networks that OSPF has received from maybe EIGRP. Now you should be asking me question now. Well, there should be some question in your mind now. That's what I'm expecting. You don't get any question now? I'm sorry, your voice is not audible for me.